Hi everyone, I'm Vlad Hale, and in this video I'm going to demonstrate Contrail with VXLAN and EVPN. So we're on Juniper Net Technical Publications webpage. We will be looking into Contrail features guide. So under configuring Contrail, there is this title, configuring EVPN and VXLAN. So this is what we are going to demonstrate in this example. This example as such is just a piece of a puzzle, so it's not an example that can be used as such. It's not an overall solution. It is just demonstration of EVPN and VXLAN functionality together with Contrail. So basically, as title says, we will be using Openstack as a virtual infrastructure manager, Contrail as a software-defined networking controller, so it's a centralized controller that we have, with EVPN in the control plane and VXLAN as a transport mechanism. So basically, what is motivation for this? Motivation we can find in RFC 7348. It's always good to read RFC because they're ultimate truth for any networking technology. In the data centers, what we face is multi-tenancy and large number of VMs and applications. So the way how previously we might have segregated customers or applications into VLANs, this number, which is hard-coded into VLAN protocol, is not enough anymore. So 4096 VLAN IDs is just not enough. Once we have a large number of customers in the data center that are all using VMs, so their servers are virtualized. Basically, very soon this number gets exhausted. Also, when we work with layer 2 technologies like Ethernet, and that is what we have usually in data centers, then there are other deficiencies and inherent to layer 2 technologies like spanning tree protocols. So basically, just if we let's quickly look into this RFC 7348. So basically what it says, this document describes Virtual Extensible Local Area Network, VXLAN, which is used to address the need for overlay networks within virtualized data centers accommodating multiple tenants. So basically what we see here is that the current VLAN limit of 4094 is inadequate in situations where we have server virtualization, where the large number of MAC addresses is needed because every server gets virtualized, and that some other technology is needed to address this issue. So let us quickly basically look what VXLAN is. So it says it runs over the existing networking infrastructure and provides a means to stretch a layer 2 network. So we are not going into whether this is good or bad, stretching a layer 2 network. We just want to demonstrate here how this works. So in short, VXLAN is a layer 2 overlay. So that is important. Layer 2 overlay scheme on a layer 3 network. And then it also says that this technology is introducing a new field, which is called VXLAN Network Identifier. And that new field has got 24 bits. So this is immediately, as we will see, the number is more than 16 million of these identifiers, and each identifier will identify basically a virtual network or broadcast domain. So basically, we can have thousands of customers in the data center, and they can all have full spectrum of VLANs, and we are still good with this number. Also, what is important for VXLAN is that is an IP transport mechanism. We cannot expect to have MPLS in the data center. and this is clearly stated here. So it runs over UDP, and basically there is no MPLS. What we are going to demonstrate in this example is stretching of layer 2 network from virtual world into a physical world. So again, in the data plane, we are going to use VXLAN. In the control plane, we are going to use EVPN. When we say EVPN, we are thinking MPBGP. Once we know it's MPBGP, we should feel like at home. Why? Because we know MPBGP is super scalable. It can carry any kind of information. In this case, it's going to carry MAC addresses because we are again at the level 2. Are these technologies basically somehow tied? No, they are not. And EVPN actually, when it works together with MPLS, it completely obsoletes VPLS. So EVPN addresses all deficiencies of VPLS, and together with MPLS makes VPLS obsolete technology. So VPLS is the thing of the past. Also, VXLAN as such can work with another control mechanism called OVSDB, and that is used for bare metal server integration. And probably in one of the next videos, we are going to demonstrate this functionality as well. Contrail supports OVSDB as well. But in this video, we are just going to demonstrate VXLAN and EVPN. So where do we start? For this recipe, we need, again, let's see what entities do we need. We need control node, which will be Openstack and Contrail. We need a compute node, which is an x86 64-bit server. In the hypervisor of this virtualized server is this entity called virtual router. So this is a Contrail's forwarding entity, forwarding component. It is a full-blown layer 2 and layer 3 forwarding component. In this case, it is going to work at layer 2. Also, I'm going to use a physical device which understands VXLAN and which also can communicate EVPN with the Contrail. It so happens that in my lab I have an MX device, and I'm going to use this device, but not in the sense of MPLS, but only in the sense of VXLAN. So here we don't have MPLS. That is also important always to stress. The other thing is that we are going to have a layer 2 overlay on top of layer 3 network. So where is my layer 3 network? There it is. Do I care about this network? No, as long as this network can know how to route IP traffic, we don't care what kind of equipment is here. So the only requirement is that this network can route IP traffic. So this network is called IP underlay, and basically this is where over that network we are going to establish VXLAN tunnels. So again, what is the idea here? The idea is to connect this virtual machine that is instantiated on this compute node and this bare metal server that is connected to this MX. They both live in the same broadcast domain, as we can see here. So I already have a VM that is instantiated. Let me just quickly show you this. At the moment, I can see this VM only through OpenStack console mechanism, as I cannot SSH, there is no routing, I cannot SSH to it. But what is important here to observe is this MAC address. This MAC address here, because that MAC address will have to be somehow transmitted, actually transferred from a virtual router. So from here, from the virtual router, it needs to be transmitted here onto this MX device. So again, I'm looking into this. This is a little Cirrus VM machine. So we see its IP address, very easy to remember, 222.1, and this MAC address. So let me just ping bare metal server. And that ping obviously is not going to succeed, but we will prepare everything to observe what is happening when we establish full connectivity. On the other hand, here I have my bare metal server, and I can quickly just observe its MAC address, which is this one. And also, if I try to ping my VM machine, that will be unsuccessful as well. So we are now in the base config on this MX router here, and run show BGP summary. My BGP session is this one. This one is important. Actually, 22 is in active state. So obviously there will be no pings. But first things first, I've just connected this bare metal server to the MX. So what do I need? I need basically to connect this to a particular instance, which is a virtual switch instance. We are on the layer 2. On layer 2, we are talking about virtual switches. So virtual switches are those entities that enables us to do segregation on MX. So the similar concept to VRFs, but because we are on the layer 2, we are going to need virtual switch. So I'm going to add this virtual switch now to my MX device. So let me see. So this is rollback 1. Show compare. So this is a config that I'm adding. Let us observe just a few things here. So what I have, this is interface that leads to the bare metal server. This number here, VNI 555, that is basically this identifier here. So that identifier will serve the purpose of enabling particular MAC address to end up in a particular virtual switch. So this is my designation for this broadcast domain. So this config is a classical config. There is nothing special about it. So let us commit. Okay, nothing has changed here. So I still don't see my pings working. So let me check what I have basically in the table of this virtual switch. So I see one type 2 route and one type 3 route. This type 3 route, basically, that is for ingress replication because I need to know how to deal with boom traffic, broadcast, unknown, unicast, multicast. But this route is just, we see that virtual switch has learned the MAC address of basically of this bare metal server and nothing more. I still don't have MAC address of the virtual machine here. So I'm missing something. What I'm missing is I need to introduce a control plane here. So let us add multi-protocol BGP family EVPN signaling. That should help. So that is rollback 3. So I'm enabling family EVPN signaling. Commit and show BGP summary. The session is still active. Okay, the session is established and we see that pings have just started to flow. This is very good. Let us just check our virtual machine. It can also ping bare metal server. That looks good. So let us check now virtual switch table, and we see more type 2 routes. So what I see some BGP routes, and I see type route number 2, and we see virtual machine IP address and its MAC address. So that is a good sign. So basically the MAC address of this virtual M through MPBGP has been transferred into this virtual switch instance. So that is good. And let us just quickly observe MAC address. Let us just quickly see what it looks like actually in more detail. So we see a route label 555. So what is route label 555? That is, if you remember, that is this basically virtual network VXLAN network identifier here. So this is that number, and it's been carried in the this type 2 route. So that looks good. And what we have established with these pings, we see that VXLAN tunnel is live now between these two endpoints. These endpoints are called VXLAN termination endpoints, and they're responsible to put the whole Ethernet frame into this UDP packet. So basically the whole Ethernet frames is being transmitted actually in this VXLAN tunnel. To be certain actually that is what is happening, I have a sampling enabled on this core interface here. So basically, let me just check, and I'm checking UDP port 4789, and as we can see, UDP protocol 17 port destination port 4789, and we see that packets are really basically flowing from the loopback address of this MX to the compute node, which is .18. So between these two devices, the VXLAN tunnel is established. So that is all good and well. But what happens? This network is just super isolated. I cannot reach my virtual machine. There is no routing. So what good is that? So how do we actually get routing enabled in this setup? And for that, we need to move one layer up. From layer 2, we need to go onto layer 3. And how do we do this on MX? We need to introduce virtual routing and forwarding instance. So basically, let us add a VRF. So this is rollback 5. So what I'm going to do now, I'm going to add basically a VRF, simple VRF, and with a loopback address. Okay, this is also run show root table VRF, but still I only see a loopback address in my VRF table. So how do I glue together these two instances? I have virtual routing and forwarding instance, and I have virtual switch instance. But how do I glue them together? And there is an interface that we use for this purpose. That interface is called IRB, and that is integrated routing and bridging interface. So this interface has it is actually it shows certain duality, and that duality is that it can see into both of these VRFs. So it can do bridging when it needs to do bridging, and it can do routing when it needs to do a routing. So basically, let us add IRB interface and see now what we get with that. So this is rollback 7. I'm adding IRB with the IP address from this network. I'm putting IRB in the VRF, but also I'm putting this routing interface in the bridge domain that is in the virtual switch. Okay, let us see what we get now. So now what I have is my network is visible. There it is. 222.0.20.24 is visible via IRB interface. So basically, let me check. Can I SSH now to VM? SSH zeros at 2.2.1 routing instance via ref. And here we go. I'm now on my VM from the basically from the VRF that has this loopback 11.11.11. So basically routing is enabled now, and what we have proved is that MX is a true VXL3 gateway. What does that mean? That means that MX has capability to route between different VXLAN networks. Although I'm not depicting here a second VXLAN or third VXLAN network, MX, its ASIC has this capability. So what we have achieved is basically using these two routing instances, we have enabled routing, and also we have extended this network all the way from the virtual world to the physical world. So this concludes this demo, and see you soon. Thank you for watching. Bye bye.